welcome back. This is the third chapter on linear equation. Here I will explain some more concept that will be useful for you definitely. So let's start with on the depending on the discussion that made on the first chapter itself, where I have already explained that equation is equation is equality between expressions. Okay, equality between expressions. Okay, now I will take a very simple example of expression. Let's say x plus 2 and x minus 7. These are two expressions. Now if they can be equalized, means on some basis, if I equalize this, so this is an equation. Okay, definitely. And for some value of x, the left hand side, that means this part, has to be equal to right hand side for any value of x. Okay, now this is right now in a equilibrium form. Now if I disturb that equilibrium, as if you remember, I have given an example of balance where a fixed weight is there and I am equalizing with a standard weight. So until I get the exact weight, it won't be equilibrium. So once it is getting equilibrium, so I can able to find what is the weight of this part from this standard weight. Now if I disturb this, means if I take out some of the quantity out of it, I make it a small one, so this again equilibrium breaks. So the same things if I do it here, so x plus 2, if I add plus 7 both side, okay, so will it change its equilibrium? Because I am adding both way plus 7. So if I add something here and the same equal weight here, it won't change its equilibrium because I am putting the same weight. That means once the let's say the dead weight is 10 kg and I am putting slowly 10 kg, that means 2 plus 2 plus 5 plus 1, like that I am just reaching that equilibrium. Then after I am putting some dead weight of equal of 2 kg, and then again I am putting 2 kg here, so that means this equilibrium will not break. So until I am putting the same thing on the both sides, it won't change its equilibrium. That means here I can say x plus 9 is equal to then 7 So this also true if this is true. So this also satisfy for the same values of x. So this also, but here you can see the expression changes. So you can understand, so expression is not static. Expression may vary, but the condition of equality will be same even if it is the expression is different. Okay, so don't understand that if two expressions are equalized under some condition, then if the expression changes, the equilibrium also will change. No, because to change the expression I am adding, or that could be a subtraction. This case I am adding, this could be a subtraction also, to maintain the equilibrium same, because I am treating the both left hand side and right hand side equally, just like the balance. So why I'm explaining this, it will be useful later on because it's a very easy concept if you understand that to solve, and later you need not to think like that. For understanding I'm just explaining, so you can understand expression if it is related in some equation, then even if it is changing the expression, the equilibrium doesn't change, but in the same condition, if I treat it only one side, let's say I'm adding 7 here, I'm not doing nothing, then definitely this expression or equilibrium will imbalance. So that means if I put something here, I'm not putting the same thing there, so that means where I'm adding, this definitely will be heavier and it will be more than the other side. So this will be an inequality. So any inequality you cannot solve that has a erratic or variable solution, that doesn't have any fixed solution. So I can only solve equation which is coming equality. Means equation itself calls equality. So in case I find any inequality which will not give you any fixed value of x, I cannot solve it to reach some perfect value or fixed value of the variable. Okay. Then the later this I have explained with one variable, and now there could be any such equation. So to solve it, let's say x plus 2 I have taken is equal to x minus 7. So is that equation holds good? Because you see the both the side, the variable is coming with a order of 1 and their prefix are also same. They are not coming with any different prefix. If this is the condition, if variable is same, this is almost like a constant. That means if I take the balance and if I know there is a variable of equal variable, means this and this, because I cannot keep the variable on both the baskets. Okay, I have to keep variable here and I have to put something which is known here. So if both sides the same variables are coming, so there is no chance of balancing each other because these are already balanced. So any extra addition to any side, it will make it equilibrium, or any deduction on any side, it will make inequilibrium. So that means if I see that variables are same on the both side, I cannot do any equilibrium business with this condition, because if variables are same, let's say I am keeping one coconut here and coconut here, both are same in shape and size, so balancing each other itself, so no need of dead load to understand what is this value, because they are, but in this case I cannot understand what is the weight of this unless and until I put something which is standard. So I cannot solve this kind of equation because this will not give you something some freedom to find the value of x, because x are there on the both side of equal quantity. Understood? So such equation is not possible. Whereas I have taken that example to understand you the earlier concept, but here again I am just explaining if this is the situation where both the items are of same shape and size, I cannot equilibrium it by putting something else there. Rather, I can put it same side. So putting same side means this will be added. So if I want to bring it this side, it has to be something on negative side. That means this has to be brought to make it positive. So this has to be something nullified, means if I physically if I remove it, so it is already negative. So if I remove it, it will give on only x. So if I remove it, it will be equilibrium. Then again I put back 2 on this. So there will be 2 coconut, and that case if I bring it this side, or so variables are there in one side, and I can put anything to make equilibrium. If let's say this together gives the value equal, then this way I can find the value of x. So you have to understand how the equation given or how the expressions are related. If it is related as I have explained, so then only you will able to find the legitimate or the real solution of that variable. So let's do some calculation or some mathematics on expression. Let's say an expression is given x plus 2 is equal to 7. To start with, as I told, this is left hand side, this is right hand side. I will take out the constant from here, and I will take out the same from the right hand side from the constant, because this is excess. So I have already put 7 to find this equilibrium. Now I am disturbing the equilibrium by deducting some of the constant quantities that I know the fixed quantity, and the same from the dead weight and from the standard weight I am removing. So it will give x, and here I will find 5. So this is also a form of equality, this is also a form of equality. But here I can find the value of x as 5. For 5 value, this equilibrium also sustained. This also can sustain for x plus 3. If it is 8, this also give you x is equal to 5. So equilibrium condition could be different, expression could be different, but value, the real value of the variable will be same for different kind of expression. Okay, so you just go through your textbook and try to practice more at home, so that you can come across any doubt. If it is come across any doubt during your practice, just let me know, put in the comment section, so that I can help you better, and follow my classes serially, not haphazardly. Otherwise you will lose your concentration or interest too. So thank you for now. Good night.